I do have one slide. And first of all, good morning. And just like to make a clarification, the NIH is actually not a regulatory agency. And so unlike my colleagues here, we don't have that auspicious authority, but we do fund the program. In fact, the majority of this, along with my colleague from NIBIB, is managing and funding this program along with DARPA. And so what I have here is essentially a summary of what the discussions were from yesterday. I think we can certainly have heard from the discussion that this is really all about convergent science. We're taking the best of physics, material science, bioengineering, microfluidics, stem cell technology, and really converging the best aspects of this technology and coming up with the human on a chip. And I think with what we've heard yesterday is that the great potential of the organs on chip can essentially be fully realized primarily from the IPS field in terms of maturation of that technology. What I have here is showing sort of like the potential benefits or potential applications that we can get from the organs on chip or human on a chip once it's all integrated. So what we have right now, as you have heard from Lance and Jonathan and Julie, are standalone chips. And that was essentially the goal of the program in the first 2 years, was to create physiologically relevant organs on chips. Now, the next 3 years of the program would be essentially an integrated organs on chips, and that's where we're going to come up with a human on a chip system that hopefully can be used in terms of, I see it as primarily two main uses. One would be on efficacy and certainly disease modeling, looking at pathomechanisms, and even personalized medicine would be one great use. And then the second of that would be in terms of safety and toxicology assessments. And so you can, as you can see in the slides, eventually what we hope that were the potential use. I think when Marilee asked, where do you see this 5-10 years out? I think my goal certainly is to take the human on a chip and essentially use this as a tool, maybe not in the next 3 years or so, but certainly 10 years out, as actually being able to do and conduct clinical trials on chips. Because that is where the IPS technology can come about in terms of being able to capture demographic representations of different populations and being able to represent that. And I think, I don't know if Tony's still here, but certainly one of the great feedback that we've been getting from pharma is being able to capture the genotype of people who have gotten adverse events, putting that on the chip and seeing if we can recreate that on a chip and what that looks like on a chip. One advantage also of using this would be to capture the genotype of individuals with rare diseases. And I think even when that person is no longer with us, I think in terms of being able to get that particular representation of the mutation on the chip allows us to be able to do risk assessment in terms of candidate therapeutics, even when that person is no longer there. So effectively, you're increasing your rare disease population in some ways historically using archive materials. And so you're in some ways your sample size for the clinical trials increases. And then of course as I've shown in here, you can look at the microbiome effects. So you can look at essentially environment and environmental toxins and interactions with the different cells, infectious diseases, countermeasure agents, and as I have said, tools for clinical trials, and that's where the clinical trials on a chip comes from. So in terms of what is realistic in terms of risk assessment. I'd say, certainly for standalone organs on chips, as Lance said yesterday, we're probably there in about a year or so. We're in a position to do assessments of 50 to 100 compounds and essentially be able to come up with sort of like the predictive value, or be able to come up with the predictiveness of these organs on chips. I've had PIs who are actually looking at 1,000 compounds, and that might be something that might be done also within a year. But certainly looking at the integrated organs on chips would be 3 years out from now.
Great, thank you very much. Do we have any questions? A brief question before we move on? No. Okay, Wei Shui.